You're welcome to Uniking video tutorial. In the next set of video clips, we'll be looking at a special set of numbers called surds and fundamental arithmetic operations that can be performed on surds. First, what do we mean by surds, or what set of numbers constitutes surds? We'll look at numbers generally as a superset. Numbers generally consist of two subsets, and these are complex numbers and real numbers. Now we split real numbers again into two further subsets, which are irrational numbers and rational numbers. By irrational numbers, we are actually referring to numbers that cannot be expressed exactly as a fraction. Take, for example, something like, should I say, root of 5. I can't express this exactly as a fraction, say as a fraction a over b, where a is an integer and b an integer. But if I have something like, say, 2.5, of course we know that we can express this as 5 over 2. We can express this as 10 over 4, right? But a number like square root of 3 cannot be expressed as, say, p over q, where p is a fraction. Sorry, p is an integer and q is an integer. This is not possible. Such numbers are regarded as irrational numbers. There are so many numbers that fall into this category, even something like pi, which today we just look at pi. We say, oh, pi is 22 over 7. Pi actually is not 22 over 7 exactly. This is just an approximate representation. A large population, or almost 100% population of the numbers called surds, are irrational numbers. They constitute numbers that cannot be exactly represented as a fraction. So I'll say that surds are a special class of irrational numbers. Say root 2, root 3, root 5, root 7, root 13, root 11, root 17, and so on and so forth. However, some surds do have exact values, something like root of 9. Root of 9 will give us an exact value of 3. But those are not the kind of numbers we are actually looking at here. We are actually looking at the ones where we cannot get an exact values for them, like the root 5, root 2, root 3, root 7. How do we manipulate these numbers? What are the basic arithmetic operations we perform on them? And how do we perform these operations? This and a few more are what we'll be looking at in about 6 video clips under the topic surds. Basic operations on surds. We can carry out our normal algebraic operations like multiplication, addition, subtraction, division. Let's look at the first operation we want to look at. Here we see that if I have the surd of two numbers multiplying themselves, say 7 by 3, that this can be expressed straight away as the root of 7 multiplied separately by the root of 3. That's why we are told that the root of what? M times n can be expressed as the root of m times the root of n. But please take note that if I have the root of 7 plus 3, this can never be the root of 7 plus the root of 3. So it is for multiplication, and addition cannot work, neither can subtraction work. So this is wrong. And also something like 7 minus 3, we can never say this is going to be root of 7 minus root of 3. If you doubt this, we can look at something like say 25 minus 16 and find the square root of this and see if this will give us square root of 25 minus the square root of 16. 25 minus 16 is 9, and the square root of 9 will give us 3. Let's see if that will give us the same thing here. This is going to be 5 and this is 4. And you can see that's 1. So they are not equal. Also, as a second rule, we have here that division also, if I have the root of 7 over 3, I cannot. We can put this as the root of 7 divided by root of 3 will give us, separate it as root of 7 divided by the root of 3. Now with these basic operations, we'll try to see how we can manipulate more Surdic expressions. Let's look at this. We are told here, simplify root 50. How can I use the rules that we have just learned to simplify root 50? That is, give us this in a simpler form. If this is root of 50, anytime we are asked to simplify a Surdic expression, we simply look at the number there, 50 for example, and see if we can split it into two other numbers, m by n, where one of it, say n for example, right, the square root of it cannot be obtained directly, that is a surd. I'll look at 50, I say 5 times 10, I look at 25 times 2, yeah. 25 times 2 is something more pleasant. I say, okay, yeah, I can find the square root of 25, but I can't find the square root of 2. That's exactly what I want. So I apply that first rule and I say, okay, this is the root of 25 times the root of 2. And the root of 25 we know is what? Square root of 25 is 5 times square root of 2. And that simplifies to 5 root 2. I'm sure this is not too difficult. Let's look at the second one. Simplify 125. If I'm to simplify square root of 125, I'll first break it down to two numbers. I'm sure some of us have already seen this. Two numbers so that I can find the square root of one and I can find the square root of the other. Looking at this, I see 25 again, times 5. Yes, 25 times 5 will do the job. And I say, oh, this is the same thing as 25 times root of 5. And you'll agree that this will give me 5 times root 5, which can be written as root of 5. Sorry, root of 5. So that's the first one there. Square root of 50 simplified into 25 times 2, and then the square root of 25 gives us 5, and so we have it as what? That root 50 is the same thing, right? Root 50 is the same thing as 5 root 2. And that's the second one we treated. Root of 125 split it out into 25 times 5. And that separates into what? Square root of 25 times the square root of 5. The square root of 25 is 5. And then of course we cannot simplify root 5 any further. So we have it there as 5 root 5. Let's look at 243. The square root of 243. This number appears to be a little bit bogus. But after some time, if you have been playing with indices, you should know that 243 comes from the family of what? Multiples of 3. I see this as 81 times 3. Wonderful. And of course, I've been able to split into two parts where I can find the square root of 1 and I can find the square root of the other. So I will not have committed any offense if I say this is the square root of 81 times the square root of 3. And you agree that the square root of 81 is 9. Square root of 3 remains that. So I say, okay, this is 9 times root of 3, which gives me 9 root 3. And finally, the fourth one we have there is the root of 245. 245. Well, since 5 is the end, I look at this. Can this be a multiple of 5 again? 5 into 24 will give me 4. And 45 is 9. I say, oh, wonderful. 49, I can find the square root of 49. So this is 49 times 5. Okay. Square root of 49 times the square root of 5. And you'll agree square root of 49 is 7 times the root of 5. That gives me 7 root 5. Isn't that splendid? So that's it there, the third one, and then the fourth one. You can enjoy this very well. I'll leave question 5, root of 99, for you to enjoy. That's it. Our first video clip on Surds. It's in a King video tutorial.